Hi everyone, welcome back. So, in today's session, we are going to learn about how to write a code on transaction. Okay, so in the previous session, I have already discussed about how to write the test bench top code. Okay, if you didn't see that video, I link that in the description box. You can go there and check it out. And in today's video, we are going to talk about transaction. So before going into transaction, let me give you a small review on what does our test bench top consists of. Okay, so if you see in this particular architecture, what does your test bench top include? It will be including your test files as well as your interface. Okay, and this test bench is connected to the DUT, right? In this test bench top itself. So what does your test bench top code consist of? Obviously, it will include your interface file as well as if you have written any test cases, so all those test cases will be included in this test bench top module itself. So the remaining everything is class based, but test bench top is module based. So within this test bench top, you will be generating the clock as well as reset signals. Okay, and along with this clock and reset signals, you will also be creating the instances. Okay, for what? For interface as well as for test cases, you will be creating the instances of those interface and test cases in this test bench top module itself, right? So after creating interface and test case instances, then what you will do in order to connect your test bench top, in order to connect your test bench code to the DUT, you will be connecting it with the help of DUT instance. Okay, with the help of DUT instance, you will be connecting your test bench to the DUT, right? So this is the entire code that you will be going to write in test bench top. Okay, mostly this code is same for every code that you are going to write within your system Verilog test bench, because basically what is the thing that will be changing here is interface is same, clock and reset generations are same, and of course DUT instance is same, but the types of signals they will be changing, and also the test cases. If you are having more test cases, for example, if you are developing the code for memory, you will be writing two test cases for read test case and write test case. Okay, so basically depending upon the code, depending upon the code that you are developing on the system Verilog test bench, the these things will be added, but the remaining things like clock generation, reset generation, dump file, instantiations, like creating instances, will all remain same for any code that you write. Okay, so these are the things that are permanent in your test bench top. Okay, the remaining later depends upon the code you're developing, like test cases and also the signals. So this is about the test bench top module. Now we are going to write a transaction. So before going to write about transaction, what does this transaction means, and what are the things that we are going to write in your transaction? So coming to transaction, what does the transaction means? It is nothing but the fields which are required to generate the stimulus. For example, when you are writing a code for adder, so what are the things, what are the fields that are required, what are the signals that are required in order to generate the stimulus? Because from test bench you will be passing the inputs to DUT. Okay, is it or not? Because DUT is nothing but the RTL code where the logic lies. So you will be passing your stimulus. Stimulus is nothing but packets of data. For example, if you are considering an adder, okay, so A and B, the combination, like if you are considering a 2-bit adder, so AB, which is of, like if you see 4-bit wide, if you see here, this is 4-bit wide. So the total of 2 power 4, which is 16 number of combinations will be, you can expect from that particular these two signals. So how these packets are generated, they these will be, you will be declaring them in this transaction. Okay, so nothing but fields that are required in order to generate the stimulus. So if you see here, what are the fields that are required here? So A, B and C, like A, B are the input signals and C is the output signal, and valid is one more input signal. So basically, in simple words, what are the inputs and outputs that are required for transaction, for sending the input, for sending the stimulus to the DUT and taking the stimulus from the DUT? So all these things will be mentioned within your transaction, right? So these are considered as fields. So the first step when you are writing the transaction is to generate the fields, right? So let us see what are the fields that are there and how are we going to write a code for that particular thing. Okay, so as I told you, yes. So as I told you, first you will be writing the class. All these are class based. Only the test bench top is going to be module based. So what let us consider the name as transaction itself. So this is my transaction. Okay, so class transaction, right? And then what are the fields that are there? So if you see here, let us take everything as bit based. Okay, because if you see in the code here, everything is bit based. Sorry, if you see the code here, A and B and C, right? So these are the, and they are a 4-bit wide. So let us make the class is also 4-bit wide. So what is it going to be? Bit 3 down to 0 A, right? Similarly, bit 3 down to 0 B, right? And then bit 3, sorry, it's not 3, right? It's, I think it is 5 or 6, maybe 6 down to 0 C. Yes, it is 6 down to 0 C. So these are the three signals that you will be mentioning, because these will be stimulus. These are the fields that are required to generate the stimulus. So that is why these three signals. And then now if you see what is the next step. So this is the transaction class that is required. Now if you see the transaction class here, all these A, B, C are bit based. Okay, but the thing that you should remember while doing the transaction class is, first, if you see here, A and B are input values, right? So when you are using the system Verilog, you will be using the concept called randomization. Is it or not? In order to transfer the random stimulus to the generator, because here, since it is only 4-bit wide, the combinations are less. For example, if the combinations here are more, like if it is some 6-bit wide, or if it is some 12-bit wide, now what happens? The number of combinations will be increasing. That means the number of stimulus that transaction is going to transfer from generator to driver will be becoming more. So among that, instead of doing everything in a uh, randomized manner, what we'll be doing, we will be using a randomization technique within our system Verilog code. So for this randomization technique to happen, you need to make the input signals as rand bits. Okay, when you are mentioning them as rand bit only, then only this A and B are worthy for randomization. If you are not mentioning the bit as rand bit, then you can't be doing the randomization on this particular signal A and B. Now, I didn't give any random bit for C. Why? Because the output need not be randomized. If you get the output in a random value, then your code is going to be in a different manner, is it or not? Because for the random inputs that you are generating, the output should be in a correct manner. That is why, since C is an output, I am not mentioning a rand bit for C. Okay, so A and B, these two are rand bits. Hope you got an idea on what is randomization, right? Now, so this is how you will be generating the class transaction. So in transaction, you will be using the fields which are used to generate the stimulus, and you will be making all the input signals on which you will be doing the randomization as rand bits. Okay, so rand bit 3 down to 0 A, rand bit 3 down to 0 B, and bit 6 down to 0 C. So these are the things that you will be doing. Now along with this, what you will be writing, you will be writing some function in order to display something. Like for example, you want to display these values. Okay, instead of displaying in a normal manner, what I'll be doing, I'll be displaying everything in a packed manner. Like I'll be writing a function for display, okay, where I'll be displaying everything, right? So in this way, function void display, right? So within this display, what I'll be doing, I'll be writing the code like display functions. What are the displays? Like dollar display, Okay, what I'll be doing, a equal to percentage d, similarly b equal to percentage d, okay, comma a comma b, and similarly display output c equal to percentage d, comma c. In this way, I'll be writing the display function for both input signals and output signals, and then end function. Okay, end function, and finally end class. So this is my transaction, right? So this is how you will be writing your transaction code. Now here, this is the basic transaction code. You can add or delete some concepts within here. Like for example, within the display, you can just mention some string name. Okay, you can just mention any argument. You can leave it either in a empty space, or you can just add some arguments in order to, when you want to display extra within this display function, you can all add those extras within this argument itself. Okay, like string name in order to display this particular. So let I'm going to display, what is it, like name equal to percentage is, and whatever name I want to display, I can display it here, comma name. In this way, if I want to add any extras within this display function, I can add it within the argument of this display function, right? So this is how you will be doing. And along with this, since you are randomizing the bits, okay, a and b you are randomizing. For example, if it is 3 down to 0, 3 down to 0, so that is why, as I told you, there are not many number of combinations, so you can just leave it like this. For example, if you are taking it some 8 bit, like some 7 down to 0, 7 down to 0, so 2 power 8, you will be having many number of combinations, right? So now if you want to limit the randomization bits, if you want the, if you want to put limitation on this randomization, then what here can you do? Before this function void display, you can write the constraint. Okay, like you can write some constraint, any name, like some constraint trans, okay, anything like transc. Okay, so you can say that is transaction constraint. So what is the constraint I can write? Like some a is less than 100 and some b is less than 100. So by doing this, what can you do? Only the values that are less than 100 will be randomized, and that means when you are randomizing that a and b values, then you can get only the values which are less than 100, and the more than 100 values, they will be ignored. That means they won't be providing any stimulus which is greater than 100. Only the stimulus which is less than 100 is generated by this transaction. Got it? So in this way, you can add some constraints also here. So based on our usage and based on our coding technique, we can add or delete anything in this like transaction. Just as I told you, when you see various codes in testbench shadow, you can find many number of ways while writing this transaction. Okay, some will be putting constraints, and some will be doing some assertions also. Okay, some will be writing some assertions in generators. So in this way, there are many ways in order to write a code, but as I told you, the basic code includes this fields, what are the input and output signals, and some display function in order to display the input and output signals. That's it. So basically, your transaction consists of only these things, and you need to remember one thing: on which fields you want to perform randomization, you need to mention them as rand bits. And also you should remember one thing, that the output should never be output signal. If you are considering that as output signal, then that should be never be randomized. Clear? So these are the different things that you need to learn while writing a code in transaction, right? So in the next class, we will be talking about generator and then driver. So in this way, I'll be making part by part on all these modules, like on all these components within the system Verilog test bench architecture, so that you can easily understand, and also you'll get a time to practice the code on various modules individually, instead of entirely explaining entire code in one way. I am thinking, since if you are beginners, it may be helpful for you if it is in a small and minimum way, in order to make you also practice on writing the coding and all, right? So hope you like this idea, and if you like this video, please do like it and also share it to all the VLSA aspirants. So that is all for today. Thank you.